Hi guys, so let's finish up question 3, part D of the June 2023 CSEC Add Math Paper 2. So for 4 marks, we have to prove the identity 1 over 1 minus sin x minus 1 over 1 plus sin x is equal to 2 tan x over cos x. So we normally start off with the side that is more complicated, which in this case is the left-hand side. So taking the left-hand side, I can make the left-hand side into one fraction by finding a common denominator, which in this case is the product of the two denominators of both fractions. So 1 minus sin x and then 1 plus sin x. So now I just need to figure out what the numerator is going to be. So 1 minus sin x into my denominator will leave me with 1 plus sin x. And then I have to be careful with the next part because of this minus sign here. So I'm subtracting 1 plus sin x into my denominator will leave me with 1 minus sin x, which I'm going to put in brackets. Right? And remember, I'm subtracting that 1 minus sin x. So I have in the numerator 1 plus sin x, and then when I remove those brackets, I get minus 1 plus sin x. Now, in the denominator, this is in the form a minus b by a plus b, which is an identity a squared minus b squared. So I could actually write that as a squared minus b squared, which in this case will be 1 minus sin x squared or sin squared x. Now, in the numerator, if I simplify, 1 minus 1 is 0, so the 1's actually cancel. And then sin x plus sin x will give 2 sin x. Now, in the denominator, 1 minus sin squared x, remember from the previous question where we used the identity sin squared x plus cos squared x is 1. So 1 minus sin squared x is actually cos squared x. So this fraction that I end up with here, I could actually break it up into 2 parts. So since cos squared x is cos x by cos x, I could break it up into 2 sin x over cos x multiplied by 1 over cos x. And the reason for doing that is because I need to get tan x on the right-hand side. And the only way to get tan x is if I have sin x over cos x, which is an identity. Right? So sin x over cos x is tan x. So this will be 2 tan x. And then the 1 minus cos x, of course, the cos x is still in the denominator. So we get 2 tan x over cos x, which is equal to our right-hand side. So we have proven our identity.